What's happening, everybody? It's your man, Michael Andreula, with Kathleen Mandt, Earth and Planetary Scientist who studies the atmospheres of the Earth, Mars, and asteroids. And currently they're working on a project called Rosetta. You might have heard of it. That's where a spacecraft has been launched up to an asteroid, and it is currently rotating around it. And she is working on the calculations of how the atmosphere around that asteroid, yes, it has an atmosphere, how does that work when we try to land a spacecraft on it and get samples? So we talk about that. We talk about how she got into this, and it was not an easy path, which is pretty inspiring. And we talk about the atmosphere of the Earth and Mars and a bunch of interesting things. You should really check out her Reddit, Ask Me Anything, because it's fascinating. And she's just a fascinating person. This is a true scientist, so enjoy, everybody.
The Southwest Research Institute is a pretty amazing place. Is that where you go into every day?
Yes.
Wow.
Yeah.
So you that they cover just about every possible technology you could imagine.
We do. It's an amazing place to work because as a scientist there, if you have an idea and you can get funding to support that idea, you're free to explore it as long as it's something that's legal and ethical. And so the range of research and engineering that we do is amazing.
So NASA, if they want to complete a project, they'll have you guys do some of the research and design on particular aspects of the project.
Yeah, what typically happens is NASA will put out a call for proposals because they're interested in doing some sort of research or engineering development. And then we respond to the call for proposals by writing a proposal and asking for funding to do the work.
Okay.
And that's a competitive process. So whoever writes the best proposal and has the best reputation is the one that ends up getting funded.
Wow. And this particular project, Rosetta, is the European Space Agency?
Yes, they are the lead. They're the ones who led and built the spacecraft for Rosetta, and then NASA supports by providing 3 instruments and a few scientists on different instrument teams.
Wow.
And it's really exciting to be a part of that project.
Yeah. Are we currently, and I say we like I had anything to do with it, but are,
Yeah.
are,
Well, as a taxpayer, you do.
okay, great.
So you're contributing to this.
So we have I'm losing the name of the not the satellite. What would you refer to it as? Is it a satellite?
It's a spacecraft.
It's a spacecraft.
Yeah.
Is it currently orbiting the comet?
Yes, well, it's not really orbiting the comet. It's doing kind of a triangular approach where it's getting closer and then moving away and getting closer again. And the purpose right now in doing that is to map the surface of the comet because they're going to put a lander on the surface in November. So they're trying to pick a landing site and understand everything they can about the surface environment before doing that.
And how far away is this comet from Earth?
It is 3 times the distance of the Earth from the Sun. So we call that an astronomical unit. So it's 3 astronomical units from the Sun. The distance from the Earth varies depending on its position in orbit. In about a month or 2, it's going to be on the other side of the Sun from the Earth, which is a difficulty for us because getting data from the spacecraft has to go through the Sun. And we end up with getting less data because of that, and we're limited on the science that we can do.
It's incredible that you can actually get data at all that from that distance.
It is.
So those images I've seen on there's some great stuff on a bunch of different sites, but the images of the asteroid, the comet, those have been just sent back instantaneously, or there's a long lag.
I think it's about a 23-minute lag right now because of the distance of the Earth from the spacecraft. When we put Rosetta into hibernation for about 2 years because the only power source for the spacecraft is solar panels. And in order to reach the orbit of the comet, we had to go out way beyond the orbit of Jupiter in order to reach the right orbit. And that was too far to operate the spacecraft because it was too far from the sun. So we went into hibernation for about 2 years and then came out of hibernation in January. And at that time, it took, I think, 30 to 45 minutes to get data from the spacecraft, which was a little scary because we were uncertain whether it would wake up or not.
It's mind baffling that you've actually put how when was the spaceship sent up or
It was
spacecraft?
launched about 10 years ago. That was before I started working on the project. So it's been a very long-term mission.
Do we have anything currently going out? Because technology must have exploded since the last 10 years.
Yeah, the technology has significantly changed, particularly with data acquisition and power supplies. But it's amazing how advanced the technology was even then, that we're still able to use it, that we're so successful with these missions that we have.
This is so fascinating to me. And you particularly, you come up with the instrumentation for finding out what the I guess it has an atmosphere, the comet.
Yes, comets vary in their orbit or vary in their distance from the sun. They go far out from the sun and they come close in. And as they get closer to the sun, they develop a thicker atmosphere because as they approach the sun, the water and the carbon dioxide that's in the material of the comet ends up being released because of the increased temperature getting closer. And so right now, there's not a very thick atmosphere, which is good because we're able to get very good pictures of the surface of the comet. As we get closer to the sun, the atmosphere is going to get thicker and it's going to be harder to see the surface. It's going to be harder to maneuver the spacecraft around the comet because the particles on the comet, the water that's coming out, will be coming out at 500 meters per second, which has an influence on the motion of the spacecraft. It can actually push the spacecraft away from the comet. So it's, yes, a comet has an atmosphere, but it's changing all the time.
So how did you plan? How could you possibly make a plan for that? It seems like you need to be able to improvise, but you have to have every detail laid out.
That's exactly it. This is an unprecedented mission. They've never done anything like this. All other comet missions have flown quickly through the atmosphere of the comet and then left.
Okay.
So they've just been flybys. This is the first time we've ever had a spacecraft actually come close to a comet and stay there and orbit. We're going to move out to further distances and fly in close and then move out again. And planning is extremely complicated. They have an amazing team at the European Space Agency doing the flight dynamics planning. And it's a challenge when the scientists want to do something and flight dynamics looks at the safety of the spacecraft and tells you, no, we can't. That's frustrating for the scientists, but they're doing their job because if we crash the spacecraft, we lose all the science. So it's a fun process to be a part of this.
I can't believe you're bringing so many organizations together, so many people together, and
Yes.
it's like giving birth, really.
It is. It's amazing.
It is amazing. Your Reddit AMAs, fascinating. These are things that I'm just curious about.
Yeah.
And you're an expert in, I guess, atmospheres as
Yeah.
one expertise. And
that's-
we have obviously an atmosphere that we're used to on the Earth, and there's other planets and objects out there with similar atmospheres, and you study them
Yeah.
all.
One of the important areas of research in planetary science is comparative planetology, where we compare surfaces and atmospheres and processes on different planets. Like with Mars, we've seen features where it's obvious that water has flown on the surface. And the only reason we know that is from knowing what features look like on the Earth where water has flown and then dried up in deserts, where you can see evidence for a river in the past. So comparing different planets to each other, particularly comparing planets to the Earth, helps us to learn more about the other planets in our solar system.
So how do we get so lucky? That really is it timing?
That is one of the biggest questions in planetary science, is what is the origin of life on Earth? Why is Earth the perfect place for life, but you go to Mars and you see no signs of life? We're still looking for signs of past life and hoping to find something. We're looking on Titan for signs of life, and we haven't found any yet, but we're continuing to study that. And then one of the next big targets will be Europa, which they believe has a liquid ocean underneath an ice surface. And possibly there's plumes coming out of the South Pole where the water's being released by a cryovolcano. Those are all places where there could be life, but we haven't found life yet. So that's the big question in planetary science right now.
And that cryovolcano could foster life because we have similar features.
What's interesting about that is that we've only seen a little bit of evidence, and some scientists don't believe it's been confirmed. So we really need to do more studies of Europa, more observations, and to send a spacecraft out there. But if there is a cryovolcano releasing water, it means there's heat inside, which is a source of energy which could fuel life. That's why we go to Antarctica and look under glaciers at lakes and study the life there, because that would be similar environment to what you see at Europa, where there's no sunlight. The life has to get its energy from someplace else.
How detailed? I'm particularly fascinated with the Earth's atmosphere and how it changes. And at points in history, we've had higher oxygen levels, and at points we must have had no oxygen, or did we have oxygen at the creation of Earth?
Studies have shown that oxygen levels rose when plants or photosynthetic bacteria started to become more abundant on the Earth. So life changed the atmosphere of the Earth. And the reason we have so much oxygen in the atmosphere is because of life, photosynthesis.
So when we go through mini ice ages and larger ice ages and warming and cooling, why would something like that happen?
That is something that a lot of Earth scientists are studying. We're trying to understand what influences the climate on the Earth. One thing that they've found is that there's a relationship between carbon dioxide in the atmosphere and the Earth's temperature. So when we've had ice ages and the surface of the Earth has been really cold, the carbon dioxide levels have also been very low. When the ice has melted, then carbon dioxide levels have been higher and the temperature has been higher. So there's a direct relationship between the carbon dioxide in the atmosphere and the temperature on the surface of the Earth. That's been proven through the ice core studies.
And it seems to be, I just look at statistics online, so I'm not an expert, but over the last, say, 200,000 years, we have almost cycles of fluctuations up and down.
Yes. Yeah, there's natural cycles of fluctuations in the Earth's temperature.
And this is just normal?
Yes.
Okay. And obviously, global warming, we do produce a lot of carbon dioxide and release a lot of other things. And so we can speed up the warming.
Yeah, that's the thing that's scary. The levels of carbon dioxide in the Earth's atmosphere now are unprecedented compared to anything that they've seen in the history of the Earth.
Is that why we're trying to go to other planets? And
no, I think we try to go to other planets just because we're curious and we love learning new things.
Yes, I feel like we need a very advanced propulsion system in order to really get out there.
Yes.
Do you envision us being able to create that in our lifetime?
I don't study propulsion systems, so I think I'm getting out of my area.
Okay.
But I know that NASA is funding research into propulsion systems that are advanced, and I don't know the progress of that, but I know it's an area of research in engineering and space science.
Is there any particular planets or asteroids or comets that you personally want to investigate that are fascinating to you?
Well, I'm interested in Europa.
It's
a place where we could have life. I love Saturn's moon Titan. It's also a very interesting place. It's the only moon in the solar system that has a thick atmosphere. And it's also the only place in the solar system where there's liquid on the surface. There's liquid lakes of methane and ethane on the surface of Titan. And one of the big questions is if there's life in those lakes, or if the liquid methane supports some different form of life than anything we could imagine here on Earth.
And it's coincidence that they would have like Mars basically has a very, I would say, light atmosphere. So would that be accurate to
Yes,
say?
a thin atmosphere.
Thin atmosphere. And that's,
Yeah.
if it was rotating faster, would that increase the atmosphere? I know these are silly questions, but these are
No,
probably,
it's not. I
yeah.
think it's a good question. We believe that Mars actually did have a much thicker atmosphere in the past. And what happened is the core of a planet will rotate and convect and produce and basically turn the planet into a giant magnet. The Earth is like that. It's a giant magnet, and we have a magnetosphere that puts a magnetic field around the Earth way beyond the atmosphere that protects us from particles coming from the sun or radiation coming from the sun. Mars used to have a magnetosphere, but it lost that magnetosphere because it's smaller than the Earth and the planet cooled faster and the core stopped rotating or turning. And when it lost its magnetosphere, it lost protection for the atmosphere. So particles and radiation from the sun have been driving the atmosphere off. And over time, it's just become very thin.
How would you
So
be
Mars
able,
has changed quite a bit.
how did you or we come to that discovery?
One of the ways of understanding that is the isotope ratios in Mars's atmosphere, particularly carbon and oxygen. There's most carbons have 6 protons and 6 neutrons in the nucleus, but there are some that have 6 protons and 7 neutrons, so they're a little bit heavier. And oxygen is the same way. There's all oxygen has 8 protons and usually 8 neutrons, but there's some with 9 or 10 neutrons, so they're heavier as well. And the amount of the heavier isotope compared to the lighter isotope changes when the atmosphere is removed. And from those ratios that we've measured with spacecraft that have landed on the surface of Mars, we've been able to figure out how much of the atmosphere has been lost over time.
That is incredible. It's mind blowing. I really can't wrap my head around it. And on the AMA, a lot of people asked about terraforming. Is this something
Yes.
that is? I understand it's like at some point, in a say 50 million years, at some point, an asteroid will probably come into our course and hit us. Is that not probably statistically? And we would.
Um, that's a whole area of study for NASA.
Okay.
Observing near the Earth is one of the top priorities of NASA to prevent or to at least have some sort of warning of that. We have no indications that there are any asteroids that are going to impact the Earth.
Sure.
And because we're monitoring it, I think we would have a pretty good warning. At least I would hope that we would have a pretty good warning. Another area of research is what we can do if we do detect an asteroid that's coming near the Earth, if there's any way to change its orbit so it doesn't impact us.
Yeah. And I wouldn't be asking to make some doomsday scenario. I'm just,
Yeah.
the idea is that we are, ultimately, it seems like we want to get out of our own solar system, and we're going to have to create just a huge system in order to almost leapfrog ourselves out.
Yeah.
And that would be the only reason I would be extremely interested in terraforming or any type of idea like that.
Yeah.
I know,
I,
I know you like to stick to your topics, and I appreciate that. It's just this is me dreaming.
Yeah, and actually, that's one of the purposes of science is to enable dreaming and to encourage dreaming, because that's what's so exciting about science is what you can learn about the world around you, what you can wonder, and as scientists, we wonder and then we go out and study and investigate these questions, and sometimes we learn that what we hoped for wasn't really
Yeah.
what we find out. Like our theory is proven wrong, and that's always disappointing, but that's the purpose of science. We investigate ideas and answer questions, or try to.
Were you always interested in space as a child?
Definitely. I would love to have been an astronaut, but it's very competitive to get into that
Okay.
career field.
So can you maybe give us, how you got in? I know you talked about this on the AMA, but say there's, 10-year-old kids or 12-year-old boys and girls out there, and this is something they're interested in and they
Yeah.
want to be able to do. Do you have any advice for them?
Yeah, I took a very non-traditional route to get to where I am. Most scientists go to undergraduate college right after graduating from high school. Then they go on to graduate school, and then they get a PhD, and then they work in science. What I did was I joined the military because I didn't have enough money for college at the time. And so I served in the military for 7 years. It took me 20 years to earn my PhD because I was going to college part-time and then raising children, being a military wife. So I'm the extreme of a non-traditional scientist. And it took me a long time to get here. So I think my advice to children now is to not give up. If you have a dream and you end up doing something else on the way, it's okay. Don't give up on your dream. Just keep hoping for it and looking for opportunities to pursue it. Don't think that you have to go that linear route of whatever path everybody else tells you to take. So
Yeah, that is really interesting because you were, at one point I read you were a stay-at-home mother with 2 children,
yes.
and you still pursued this to the end.
Yes.
Where did that grit come from, or fortitude?
Just love of science, really. This is what I'm really passionate about. I love science. I love space science in particular, and planetary science. And so I pursued my dream. And I was fortunate to have the opportunities, particularly with Southwest Research Institute, to be able to work there and work on the missions that I worked on. So
How many institutes are there like the Southwest Research Institute? To me, I don't think I've ever seen anything this complex and
yeah.
all-encompassing.
There are other organizations like the Johns Hopkins Applied Physics Lab out in Maryland. There are organizations out in California. We're a nonprofit institute, so what we do is not to earn a profit. What we do is to produce science and engineering results and then reinvest in our science and engineering if we have money left over. So we have a very different business model from other organizations like the aerospace companies like Lockheed Martin and others, that their job is to earn a profit, but they also produce science and engineering. So we have a lot of different organizations in the U.S.
And is this a function of maybe NASA's not taking on so many projects themselves anymore, so they need additional institutes to come up with the science?
I don't think that's really the case. In fact, what NASA is able to do right now has been reduced because of funding cuts to NASA. And people who work in space science and planetary science are struggling to continue getting funding because of NASA budget cuts. What NASA does is they try to fund the most innovative technology and the most innovative science, and sometimes that is through NASA centers, which have some amazing capabilities, and sometimes that's through organizations like ours, which also have amazing capabilities. That's why we have the proposal process where they say that they want to fund something. We submit a proposal describing how we can meet those goals, and then they decide who can meet the goals best.
So how do we change that so we get more funding into these scientific fields? Because I'll get into arguments with my friends and they'll say, don't spend the money out there, spend it on Earth, which makes sense, but not really, because the children are going to be more inspired and want to create better science. And, I'm sure there's things that come out of the Institute that we probably use every single day now.
Yeah, a lot of the technology that we've developed for space missions has had applications with our technology today. The other benefit of studying the planets is to better understand the Earth. The more we understand how atmospheres work, like if we understand Venus's atmosphere, which is a massive greenhouse gas atmosphere, the temperature on Venus is many times greater than it should be based on its distance from the sun because of carbon dioxide. If we understand how that atmosphere works, we can better understand how our atmosphere is going to change because of increasing carbon dioxide. Now, Venus is an extreme example, but it's good to understand the extreme examples so you can understand the Earth. So there's feedback into understanding the Earth. And then NASA also does research on the Earth. They're monitoring the Earth's atmosphere. They're studying ways that we can predict the way the atmosphere will change. So NASA does more than just visit planets. They really contribute a great deal to our daily life and our future.
Is there any way to manipulate the Earth's atmosphere so that if we do have incredible heating, is there, because you study, obviously, if the carbon dioxide goes up, is there any way to somehow reverse these cycles or control it?
I haven't been involved in any of those studies, but I am aware that there are studies looking into ways of reversing heating. And we have to be careful with that because it could have other impacts that we don't predict. When we look at the Earth's atmosphere and see how it's changing, sometimes it changes in ways that we didn't predict because we're still learning about our own planet. One of the recent discoveries about climate change is that the extreme temperatures that we're experiencing are going to increase as a result of the changing energy balance in the atmosphere. It's not that the Earth is just going to get hotter. It's that when it gets hotter, it's going to get hotter than it's ever been before, but also the cold temperatures are going to be cold in the extreme. So it's kind of like a wave where this is normal, but with climate change, we're getting like this with the temperatures. So more instability in the Earth's atmosphere. And that was something that wasn't predicted, but as we observe the Earth changing because of carbon dioxide being added to the atmosphere, we're learning what the impact is. So if we want to try and reverse climate change, we have to be very careful to fully understand the impact of anything we do and make sure that it's not going to have a negative impact that causes maybe increased rainfall in certain areas that are prone to flooding. We would actually be doing harm by doing that.
And we get, it's just interesting to the idea that these fluctuations have occurred in the past and what probably happened. I mean, we have had asteroid impacts on the Earth, many.
Yes.
And do you know what the most recent large one was by any chance? Do we have anything on record?
I think they track those through the evolution record where they find time periods where there's mass extinctions because an asteroid impacting the surface of the Earth will cause mass extinctions. And I believe, I'm not an expert in this, but I do believe that there are 2 time periods where they identified mass extinctions and that they associate that with asteroid impacts.
And that's just kicking up. If large amount of dust and ash also makes it colder or hotter.
Yeah, and what it also does is it creates a cover or a shield in the Earth's atmosphere where the sunlight can't get through. So photosynthesis stops. And without plants, animals can't eat, and that's what leads to the mass extinctions.
It seems like it's so delicate, this balance.
It is.
It's so fascinating. Is there any other really exciting things that like you're super excited to get to see, or data you want to see from Rosetta? Any predictions?
One of the things with Rosetta that we're interested in learning is what the comet is made of, how much water is there, how much ammonia. The isotope ratios that I talked about with Mars are also important in comets because that helps us to understand how the solar system formed. We use that to determine temperature conditions when the solar system formed and chemistry that was taking place when the solar system formed, when the Earth formed in comets. So I'm excited about that. Another thing that we look at is how the sun interacts with the comet. You've seen pictures of comets where it's this ball and then this tail flowing behind it. And it's the sun and the solar wind pressing against the atmosphere of the comet that causes that tail. And the instrument that I work on studies that interaction, how the sun interacts with the comet itself. So I'm excited to see the data and figure out what new things we can learn because we're spending so much time close to the comet like no spacecraft ever has before.
Is there anything that would surprise you about the comet?
I think a lot of things are going to be a surprise. The biggest surprise so far has been the shape of the comet. They were expecting something that's just a diamond shape, and it looks like a rubber ducky.
It does. It is. If you haven't, people listening, if you haven't seen it, you should definitely. We'll definitely cut in some pictures of it. But it's super high resolution images we're getting back from it.
It's amazing the images that they're bringing back from the spacecraft.
I can't wait until that other little spacecraft detaches and embeds itself in.
Yeah.
And then your instruments are going to be part of judging, I guess, whatever isotopes and elements come off when the sun hits it. And
Yeah.
that
And
you've just been spending so much time waiting for that to happen. I got to imagine you must be antsy.
yeah, we are anxious, and we're getting data in now and looking at it and trying to understand it. But data is so complicated that it takes a while to really understand it. So we're there, we're getting information, trying to figure out the meaning of it. And there should be press releases coming out soon, hopefully, from the mission about the first results.
I live stream, if people don't know about that, but the European Space Agency puts so much good stuff on live stream.
They do.
They
Yeah.
almost conferences all the time talking about it. It's extremely, it's good to geek out on that site. I like their site a lot.
Yeah.
So I want you to enjoy the rest of your day. This has been fascinating. Hopefully this thing lands soon and we get some data back. And
Yes.
I will be bugging you for some more answers. But is there anything you want to tell the children out there? Because primarily I would say these are 15, 16-year-old kids about to go to college listening.
That's great. Well, I think for those kids, I have a 17-year-old who's a senior in high school, and the question he's constantly asked and is so tired of hearing is where he's going to college. And that is really a struggle, because that's a point in your life where you feel like whatever decision you make over the next year is going to determine your future forever. And that's a lot of pressure for somebody so young. And I think my advice to kids that age is to just try and figure out who you are and what your priorities are and what your dreams are, and try to make decisions that will help you to achieve those dreams and those goals. And don't expect it to be within the next 4 years of just going to college. Expect it to be the next 20, 30 years. Plan and think about where you want to be that far ahead and what it'll take to get you there. And don't give up.
Yeah, that's really, don't give up and